opposition this, I think it's around October. By the way, is it Mars and Saturn, right? Mars and Neptune right now are actually in conjunction with each other. Not that that's all that special, but yeah, technically it's there. So when you're looking at Jupiter, Saturn, and Mars, you're looking at 4 planets, really.
Yeah.
All right, everybody. Thanks for listening.
All right.
See you next week.
Clear skies, y'all. See ya.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be your host this evening. I'm Dr. Elena Hyde, the director of the Allan Carswell Observatory, and we are broadcasting live tonight from the observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time in conjunction with our online public viewing, OPV, run by the Observatory team, which is running at the same hours, 9 to 10 Eastern time, local Toronto time, should I say. And if you want to follow along with our team, go ahead and wander on over to observatory.info.yorku.ca and follow the links to OPV or online public viewing. You can also just head on over to YouTube and search for the Allan Carswell Observatory and find us there. That's where the links will in fact take you. Join in the live chat, watch images, and it's a bit too cloudy tonight to see them through the telescope, so you'll be getting some wonderful stock images, I'm sure, and of course joining our team for their astronomy banter. This broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments of our past shows, or you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter at York Observatory or Instagram at the handle YorkU Observatory. Also, of course, over on Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, you can see our website once again at observatory.info.yorku.ca. So tonight I am joined by a very special guest. We have with us Blake Nancaro. Welcome to York Universe, Blake.
Thanks a lot for having me.
It's great to have you here, and we will get into all kinds of wonderful, actually astronomy and astronomer in residence things later on in the show. Now, traditionally, we always start with a bit of fun history for This Week in Space and Astronomy History, and I thought we'd go ahead and do that again tonight, even though it's just the two of us here on York Universe. But we'll go back quite a ways, because in November, it's not just 2022 that has a lot of astronomy going on. All the way back in 1680, there was an amazing comet. In fact, it was actually called the Great Comet of 1680, discovered on 14 November by Gottfried Kirch, a German astronomer. And as far as you know, he was in fact the discoverer of this comet. It's a really interesting discovery, because it was actually discovered by telescope. It was one of the brightest comets of the 17th century. So legend has it, or I should say some paintings have it, that it was even visible in the daytime with a spectacularly long tail. It was past about 0.42 AU from Earth, and that was its sort of closest approach on 30th of November 1680. Discovery of the comet meant that they could actually watch it for some time. It sped around a very, very close perihelion around the sun, and it had its peak brightness on the 29th of December, which must have been very, very spectacular. So this particular comet has been monitored by the JPL Horizons online ephemeris system, which you can actually find on their website, and it's predicted to have an orbital period of about 10,000 years. So as of 2019, just a few years ago, the comet was about 257 AU away from the sun. So it has very much been moving rapidly this whole time. So the comet of 1680 has also sometimes called the Kirch comet, and that's of course named after its discoverer, Gottfried Kirch. And we do need to give a little bit of extra credit as well to Eusebio Kino, who's a Spanish Jesuit priest who charted the comet's course. These kinds of historical observations are always really, really fun. And of course, if we want to see the comet now, we need a very, very good telescope. But the old observational records are still around, and you have some really interesting things, like there were some Spanish records from a Basil Ringrose, who was serving as under Buccaneer Captain Bartholomew Sharp, and they were about to raid the Spanish port city of Coquimbo in Chile on November 19th in 1680, and they found this comet and entered it into their logs. So it's not just a bit of astronomy, it's also quite a bit of history. This was undeniably a sun-grazing comet because of its distance, and it wasn't really, something that we expected necessarily to come back, but it is still around. And Isaac Newton, of course, could use this comets to verify Kepler's laws, and Halley's Comet, of course, being a very good example of that. So this great comet of 1680, really getting everyone very interested in comets again, and being a discovery of a comet by telescope. It sort of showed the ongoing equipment and astronomical telescope revolution happening around this time. So very fun and quite a long time ago, but still today in history, in 1680, a long time ago, this comet did come by and caused quite a stir. Have you viewed any interesting comets lately, Blake?
No, nothing lately. Not in the last probably year or so. Unfortunately.
It hasn't been a lot that we could see naked eye. I do recall it was a year or so ago, maybe there was a couple comets within the spotting of telescopes, but it does seem like it's been a while since we had a really interesting naked eye comet come by. Of course, 1680 is quite a long time ago, but this particular one won't be back for quite a while. Do you have any favorite comets?
I can never remember the names of them, but there's been a couple that I've really enjoyed. I think the one that you were just sort of alluding to, maybe a year or so ago, that we could see naked eye for a while, and it was an evening and then a morning comet, or vice versa. That was good. And then going back a few more years, there was a comet that I was able to photograph and really enjoyed that. It was really bright. Yeah.
Oh, yeah. They're wonderful for astrophotography. And of course, we're talking about comets. I do have to mention Comet Tempel-Tuttle, which is associated with the Leonids meteor shower. And the Leonids are in November, not peaking right now, but very shortly. So I think in 2022, they're set to peak on November 17th to 18th. So while we might not be able to see a comet, we can actually see when the Earth passes through debris left by comets, and in particular, Comet Tempel-Tuttle, which takes about 33 years to go around the sun, does leave a nice trail of debris for us to go through. And this November 17th or 18th, you'll see the meteor shower appear to radiate out of the direction of the constellation Leo, which should be pretty good viewing if you've got clear skies. Of course, the weather turning much colder in Toronto will not make it terribly fun, but if you've got a warm enough coat, I recommend having a look outside in the direction of Leo later on this month, or 4, 5, 6, 7, 3 days from now. Excellent. Well, that's probably enough of comets and meteor showers, although a handy reminder to folks, the Leonid meteor shower sort of tonight is going to be around 8 degrees altitude around midnight. So it's quite late at the moment. So waiting a couple extra days until it is at peak is advised on for many reasons, actually. You'll get a better viewing and, of course, a slightly better time slot.
A bit less moonlight too, right?
Yes, exactly. Days, yeah. That is quite true. We do have a moon that is a bit more than full at the moment. I think our moon phase is 63 or 64%. It's waning, so if you wait a few days, it will be going down less. So that's always nice. I do recall you're not a big moon fan.
You caught me. Yeah.
Well, it's moon is great for binoculars, but very bad for faint objects, and of course not great during meteor showers either. So these particular Leonids will be nice, having less of a moon phase, and they always have a pretty good show. All right, so moving around through history a little bit, we'll hop around and try a couple different this week in space and astronomy history. 1680 was apparently a very interesting time, and we'll be going from 1680 all the way to 1980. So November 16th, which is not quite today in history, but in 2 days and 1980. So we had Voyager 1 running around in the solar system. And Voyager 1 is a really, really interesting mission altogether. But in November 16th, one of the most interesting things that was happening was, of course, the look back of Saturn. So Voyager 1 looked back at Saturn on November 16th. And 4 days after the spacecraft flew past the planet, it looked back to observe Saturn and its rings. And so it got a unique, never before seen view of Saturn and its moons and its rings. Saturn is one of the, sort of greatly tragically unexplored objects in our solar system. We haven't been there nearly enough. And Voyager 1 getting this wonderful view of the rings of Saturn and capturing some of that complex structures. This is something that is still actively studied today. And it's hard to emphasize, I think, with just descriptive words if you haven't seen the picture. So I will recommend everyone to go up and have a look at some of these old Voyager 1 images. They showed Saturn's narrow, twisting, braided F ring. This ring, it's not just a ring, there's actual structure inside of that ring. The moon Mimas, which is also famously called the Death Star moon, it looks like the Star Wars Death Star. It has this giant crater on one side. It's ridiculous, but it's a completely natural object. It's not actually a Death Star. Don't worry. But some of the first really good images of some of these moons, we of course have lots of interest in Titan, the moon with an atmosphere, Titan's thick haze, and you can actually see enhanced images from Voyager 1 of the moon Titan's atmosphere. And having a moon with an atmosphere is amazing. And of course, what we found since then is that it really is just as interesting as we thought. Titan is the largest moon of Saturn and the second largest natural satellite in the solar system. It's also the only moon known to have a dense atmosphere, and the only object in space that we have found other than Earth on which that we have clear evidence for stable liquid on the surface. And I didn't say water, I said liquid. So Voyager 1 taking these pictures of Saturn and sending them back was hugely exciting. Of course, Saturn being a gas giant, we're not entirely sure what the under layers of Saturn's atmosphere might be like, if there is some sort of solid-ish core somewhere down there. But the structure of Saturn and its internal helium abundance was pretty much expected to be the same as Jupiter and the suns. But Voyager 1 found that actually had a lower abundance of helium in the upper atmosphere. So this might mean that maybe the interior of Saturn could have heavier forms of helium. And it may be some explanation for some of the excess heat that Saturn radiates over the energy it receives from the sun. So, of course, the Voyagers are very, very famous missions, and they have done a great deal for the solar system. But for this week in history, I think I'll go ahead and emphasize the amazing nature of Voyager 1's sort of exploration of Saturn. And the mission did include a flyby of Titan. And this hugely changed our perspective on Titan and the outer solar system. the images taken by Pioneer 11 in 1979, we had seen some evidence that maybe there was a substantial atmosphere, but this Titan flyby really, really increased interest greatly. And so I don't think Cassini-Huygens would have, well, it might have happened without Voyager 1, but it certainly didn't hurt to have these wonderful images coming back. Of course, around this mission, a lot of other very famous stuff happened. We had, of course, the first family portrait of the solar system as seen from the outside, which included the famous pale blue dot image, sort of commissioned or encouraged by Carl Sagan, which is the Earth at a distance of 6 billion kilometers as just a tiny, 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 tiny blue dot where we're all sitting. So Voyager 1 was, hugely successful and a wonderful mission. Just as a little call out, this was launched in 1977. So the Voyager 1 space probe was part of that Voyager program to study the outer solar system and, of course, continuing on into interstellar space beyond the sun's heliosphere. It was launched about 16 days after Voyager 2. So Voyager 1 is the one that came second, if that makes sense. And you can now sort of look for its current position going out of the solar system. The mission duration at the moment is something like 45 years, which is just amazing. There were also flybys of Jupiter, and its exit from the heliosphere of the solar system has been an ongoing, greatly interesting study. So both Voyagers did measure the rotation of Saturn. They pinned it down for the length of day at 10 hours, 39 minutes, 24 seconds. And of course, getting lots of extra detail that we couldn't have seen before. So a little bit of an argument for more missions to the outer solar system, maybe Saturn, Neptune, and Uranus as well. All this happening November 16th, 1980, in the midst of the Voyager 1 sort of exploration extravaganza. So this was a really fun time, and I've seen some of the Voyager 1 images, mostly in astronomy books and textbooks and things like that. But I can't imagine what it was like to see these coming out live. Of course, viewing Saturn through a telescope is very, very, very popular, making out some of the detail in the rings, but we won't get to see anywhere near what the Voyager 1 probe was able to discern. Have you ever tried to image Saturn, Blake?
Yeah, I've imaged it a few times with my very sort of basic telescope. That's been fun, and Saturn's always amazing to see in a telescope. And we should remind people that you can actually see it in binoculars too. It'll be tiny, but if you can view it in binoculars and keep them steady, you can see it's kind of a football shape, and you can probably see the moon Titan around it as well.
That's an excellent point. And it is a very viewable non-spherical object. Even with a minor amount of magnification, you can see that it is definitely not round like the other planets. And if you have reasonably good binoculars, maybe the nice Celestron ones or something, you'll definitely be able to see that it does in fact have rings. So this is a great starting target for observing. And I believe, if you wanted to get a little detail on the rings, you probably would need an actual proper telescope. I think the Cassini division tends to need a reasonably good telescope and clear skies. I'm not aware of anyone being able to get the Cassini division with binoculars, but I could be wrong. I'm happy to be proven wrong.
And Saturn's visible right now too. So
yes.
If anybody's clear skies where they are, it's visible now, which is great. And you would look off in the southwest and you'd be able to see it. It sets around 11 o'clock, so it's visible kind of when it gets dark, and up till about 11 o'clock each night for the next few weeks.
Yeah, exactly. So rising around 1 and setting at 11. And if you're out there, looking tonight, Mars is also rising around 6:30 p.m. And Jupiter will be up as well. So Jupiter's going to be up a little bit longer than Saturn. So Saturn sets around 11 and Jupiter sets around 2 a.m. So there's a good planet viewing at the moment. If you've got those binoculars we mentioned before, maybe you could go out, look at Jupiter, and then look at Saturn and look at the difference. But yes, it's a wonderful night for planet viewing, because of course they are nice and bright, so that moon phase won't bother you too much, I hope. Excellent. So do you have any favorite Voyager 1 memories, Blake?
Well, I remember those photos when they were coming back, and I too, enjoyed seeing the color renditions of those in books and magazines, and I think that was sort of when I was starting to get interested in astronomy, and what sort of encouraged me. I remember clipping out the newspaper articles and keeping them when they launched the Pioneers and launched the Voyagers and so on. Yeah, and I every once in a while I use a website to figure out where all those probes are right now, and it's fascinating to know that some of them are still functional, even though very far away.
Absolutely, and I think that is one of the really interesting things about the Voyager program is, of course, just how far they did make it out of the solar system. I'm not sure what the distance is now on those two, but they have actually gone pretty far. They're headed for, of course, interstellar space, and I believe their current mission status is, whether or not they've fully reached interstellar space is a little bit of debate, but they're many billions of kilometers from the sun at this point. I think it's something like 20 billion kilometers. So this is incredible distances. And it is really quite amazing that we're still able to get any kind of response from them. Wonderful missions. All right.
I just found the distances.
Oh yes.
So Voyager 1 is I'm rounding 159 astronomical units away, and Voyager 2 is 132 astronomical units away.
Excellent. Well, considering that they both started at 1 AU here on Earth, that is a quite the travel plan they've got there.
And they're still working.
Absolutely, and they are being tracked by the Deep Space Network. I know the DSN in Canberra, Australia, is often used to make the connection. And it's I can't wait to see how long they keep going for. This is great. Excellent. Well, let's see. We have Voyager 1 from 1980, hopping around in space and time a little bit. I do have one more this week in space and astronomy history. And as they say, a no for something completely different. So rather than talking about space exploration, I thought I would tell you something that is a little bit related to space, but kind of just a really cool thing that happened in adjacent to astronomy around this time. So on 11th of November, which is 3 days ago, but in 1930, a U.S. patent, I believe it had a very long patent number, 1,781,541, was issued 11 November 1930. What makes this patent very unusual, it was actually issued to Albert Einstein and his former student, Leo Szilard, who co-invented the Einstein refrigerator. And this is really cool. So I just had to bring this up because it's not technically astronomy, but it is part of astronomy history. And of course, developments in science and developments here on Earth often go hand in hand. So the Einstein refrigerator being patented in 1930 and having this U.S. patent number, you can actually look up that U.S. patent number and find the patent for this refrigerator if you so wish. It will show up as a Google image, and you can download the image and try to make one at home. Just be careful. This was a really interesting patent because it's not just a refrigerator patent, it's what's called an absorption refrigerator. It was pretty revolutionary, as you might expect for something patented by Einstein, but it has no moving parts. It only uses heat as an input, and it was, co-awarded, and unfortunately, or I don't know, maybe it's not that good of a refrigerator, but it was not immediately put into commercial production. This and many of their other patents were acquired by a Swedish company called Electrolux. And this refrigerator is a really fun example of sort of a thermodynamics almost experiment. It has, as I say, no movement parts. It operates at a constant pressure, and you just need a heat source for it to operate. It needs 3 working fluids, and it has water, ammonia, and butane. And basically what it does is it sort of circulates these around through 3 different chambers, and you'll have to look up the patent yourself if you want to see the full refrigeration cycle. But the goal of this was to remove moving parts and eliminate the potential for seal failure, because of course if you have moving parts on a refrigerator, the seals could flex, or anything that could move, you could get some sort of seal failure, and it wouldn't be as efficient. So they actually were granted 45 patents in 6 countries for 3 different models of this Einstein refrigerator. So a lot of people sort of debate about who did what part of this refrigerator design, and Einstein sort of contributing to the design work, and César basically doing the paperwork, or who did what part of it is a little bit unclear. But what is clear is that they weren't actually able to make it more efficient than what was existing at the time, unfortunately. So it had no moving parts, which made it very, very reliable. But the refrigerator they designed couldn't beat what was there existing already. So the current existing appliances of the time, I suppose I should say. The patents that were bought up by Electrolux, a Swedish company, basically earned them about $750. So I think if you convert that, it's around $10,000 modern money, which is not a huge amount for an ongoing patent. And of course, around this time, we also had the introduction of non-toxic Freon, which unfortunately was then later found to be responsible for serious depletion of Earth's ozone layer. So, pluses and minuses. There was a variant of this refrigerator actually using an electromagnetic pump, which had compressed a working gas pentane. I think instead of was it butane? I think that I said. But it's interesting, and it's a very intriguing design still. And unfortunately, despite modern advances, this particular design is really not close to being commercialized. So it's more of an interesting thought project than a practical design that you would want to build, but very, very fun for physics and engineering students, I'm sure. And of course, the fact that the patent was originally filed this day in history just goes to show it's, scientists are multifaceted too. So having a side interest in refrigeration is pretty cool. Sorry for the pun. But yes, I'm not aware of anyone else in astronomy inventing any refrigeration components. How about you, Blake?
No. Off the top of my head, I don't know of any.
Well, there are always interesting inventions happening in science, so it's a wonderful thing for today in history, and a nice little reminder. So I'll go ahead and speaking of reminders, just go ahead and remind everyone that this Wednesday we will be having a teletube over on our Observatory YouTube channel. So if you are interested in following along, that is going to be on our main website, observatory.info.yarku.ca, and you can find the link to teletubes just up at the top with the rest of the schedule. And since it's about the midway from the show, I'll go ahead and remind everyone as well that, in fact, you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. That website again, observatory.info.yarku.ca. For chat, questions, or content, you can always check with us on Twitter at YorkU Observatory. And of course, our online public viewing, our OPV team, is currently running on YouTube with a live chat and wonderful astronomical images. Tonight, you're listening to Dr. Elena Hyde and our special guest, Blake Nancaro, and we're discussing, refrigeration, among other things, and the Seek in Space and Astronomy history on our way to talking about the Astronomer in Residence program. So, getting us all started here, for those of you who haven't heard, the Astronomer in Residence program was run for the first time ever for the Allan Carswell Observatory with the Killarney Provincial Park. First time ever this year in 2022. Now, just to tell you a little bit about this program in case you haven't heard of it, it's pretty cool. The Killarney Provincial Park in Ontario, Canada, has an observatory, and as part of our partnership with them at Allan Carswell Observatory, we help them to find astronomers to run programs all summer long. And this was the Astronomer in Residence program, or as we call it, AIR. The program started this year for the first time, and we had astronomy outreach, we had astronomy hikes, we had astronomers in residence all summer. But the very, very first astronomer in residence for this first program was actually Blake Nancaro, who I just happened to have with me tonight. So thank you, Blake, for joining us.
Yeah, good to be here. I'm having flashbacks to May.
Yeah, indeed. So that was, of course, May, your first astronomer in residence, May 9th through May 29th of 2022. Blake was the very first astronomer to drive out to the parks and set up with the observatory. And as the first, we had all kinds of interesting things happening. But to get us started, Blake, what led up to you deciding to apply for this astronomer in residence program out at the park?
Well, partly you kept dropping hints.
It's my fault.
Yeah, you and I were talking a couple of times about various things, and you dropped a few hints that the program was starting up and that anyone could apply. So I looked at all the information that you had provided, and because I work freelance, I can kind of control my schedule, and the work that I was doing was in a bit of a quiet time, and I called my client and said I'd like to take a couple of weeks off, and they said fine, and that was sort of two of the big things, your encouragement and and that I was able to kind of clear my schedule and head up there. Knowing that they had internet access to meant I could still do some work when I needed to. But that's what sort of got it all started for me.
Wonderful. Well, I know you did go up, of course, that first week in May, that May 9th week when you started off. You did have a couple nights of cloud and I believe some fog as well. And being the first one there, you were also working on documentation in addition to the telescope setup. And was it which dome did you start with? Do you remember?
I think I was focused mainly on the primary, if you will, dome, with the big sort of telescope in it, just because that was what I was least familiar with. So I kind of wanted to get up to speed on that one as quickly as possible. The other dome, the other Skyshed pod, that has a telescope that was much easier to use. I knew I wouldn't have any trouble with that. That was just sort of my focus, was to learn this new system, relatively new system, as quick as I could and get comfortable with it, so to be able to help you out.
Yeah, and just for folks that might not have seen the observatory, it's totally recommended to go there next summer when we hope to run again. But the two domes that Blake is referring to are the Chi Wasa Dababang Dome and the Wasa Dababang Dome, which is they both have names based off of indigenous indigenous descriptions, and the two telescopes are a 16-inch Meade Series 6000 and a 10-inch, which is in the other dome, and the 10-inch is a Meade 10-inch Schmidt Cassegrain. And those two different telescopes are basically kind of in different operations mode. The 10-inch is the smaller telescope. It's been there for longer, I believe, and it's really, really common to use that for solar observing. And I think you did have some solar observing when you were there, but not on the first week, as I recall, Blake.
Yeah, the conditions were not great on some of the days, but we did get some good solar observing in, and we had some daytime astronomy for people, and we did have a bunch of visitors that enjoyed looking at the sun safely, of course, with a solar filter attached. And we did enjoy some good views of the sun with a full spectrum filter or a white light filter, where we were able to see a number of sunspots on the surface. So
exactly, and you were actually there.
That was pretty rewarding, yeah.
Yeah, and that was just when the sunspots were just starting to take up, because of course now we're going into a more active sunspot period. So it was a really good coincidence, and actually that's a good tip for anybody who is looking to perhaps do some good sunspot viewing. If you do have a reasonably sized telescope, get one of the really good filters. Eye safety first, and you can watch the sunspots go by day to day, I should say, not night to night.
Yeah, we had some really good sunspots, and there were a number of different groups. So I was comparing that to some of the satellite or space probe imagery and identifying them and so on. So it was quite good. We saw active region 3014 and active region 3015 and 3010 and 3016. So 4 separate sunspot groups were visible to us.
Yeah, that is really one of the great fun things about watching the sun is it changes so much on a relatively short time scale, that you can actually see changes, on different days. And of course, we're talking about the sun, but while you were there, we actually had a lunar eclipse, and this was our first ever live stream on YouTube from Killarney Park, our first lunar eclipse of the year, and the first astrophotography ever taken place up there. So that all happened while you were there, and I believe that was during your first week as well.
Yeah, May 15th was the the lunar eclipse earlier this year. Of course, there was lots of hubbub in the news just in the last week or so with the current or recent lunar eclipse, but we had a similar one in May, and it was advantageous, that one in May, because for us, at least in Ontario, it was much higher in the sky as opposed to being near sunset and close to the horizon. So it was pretty spectacular. We were all really happy up there at the park, and also really happy that we were able to send down images because of a good internet connection. We were able to send down our live stream views for you guys to enjoy.
Absolutely, and we actually got clouded out here in Toronto, but we're able to play those on the projector at the Observatory atrium. So it worked out absolutely amazingly. And if anyone listening does want to see the live stream eclipse footage, it is still on the YouTube channel. So head on over if you would like. Now, lunar eclipses are really colorful events. Of course, if anyone brave enough to wake up at 5 o'clock recently could have had a chance to see this more recent one, but the one that happened in May of this year was, as you say, much higher, very, very spectacular. And of course, we're not even going to get a lunar eclipse next year. We're having a bit of a break, so we had lunar eclipse extravaganza happened during your trip, which was absolutely wonderful.
I've seen lunar eclipses before, so it wasn't unique or sort of something that was uncharted territory for me. But there was something really special about that one in May. I think it was partly the elevation, partly that we had really good sight lines, and the crowd that we had there at the park, they were really into it, really enjoying it. But what really struck me was how dark everything became. At mid-eclipse, I was really, really surprised at how much of the sky I could see. We could see all the stars, of course, in the Milky Way around or behind the moon. And, it was a full moon, but it was completely darkened by the Earth's shadow, and it was a deep eclipse. So it was really interesting, just the experience on the ground in the park. I just really enjoyed it. So it was one of those goosebump moments, even though I've seen them before. This one was really good.
Yeah, and I have to say, I have felt that myself. Is just even viewing things that you have seen before, because of course, Killarney Park is a certified dark sky site, and the difference you get at these very, very dark skies, it's hard to put into words, but you can all of a sudden you can see things that you normally wouldn't be able to see. Even the Andromeda galaxy is a naked eye object out there, and it really it does add quite a lot to the observations, I'm sure. And it's so you've all heard it from the experts here as well. Did you get to view anything else in those dark skies that really impressed you, Blake?
It's kind of a funny thing, because you had asked me why I had decided to go, and I wanted to help out in May and so on. But when I got up there, I thought, I've made a terrible mistake, because the moon's really bright and I'm in the full moon phase. but I was glad that I had planned to stay on for a longer stretch, for a 2-week stint, because every night after that lunar eclipse, it was getting darker and darker each night. So I got to enjoy those dark skies more and more through the balance of that trip or that visit. So it was fun imaging other targets like Messier 53, a globular cluster, and we got really good images of the Owl Nebula in Ursa Major, and we also viewed imaged the Black Eye Galaxy. So those were sort of fun to do. And I had kind of a couple of little personal projects that I wanted to do. I wanted to do a nice star trails image, and also do a tracking image where I was making my camera move. I brought my barn door tracker that I had made and tuned it and adjusted it properly, and did a sort of a motion track on one of the evenings. So I was able to get a really sort of rich, deep view or photograph of the Milky Way after stacking up a bunch of images. So those personal projects that I wanted to do were fun. I had to work out some camera glitches as usual, but that was being able to take advantage of those dark skies. So that was good.
Absolutely. And of course, just for anyone, again, listening, a lot of these images are, in fact, on Blake's blog that we have on the Observatory website. So I've been telling you the website all day, but it is observatory.info.yorku.ca, Astronomer in Residence, and then just scroll down to the first couple weeks of May, week 2, week 3, week 4, and you'll find Blake's blog there with all these wonderful images, and they turned out amazing, Blake. I think the Star Trails is my favorite one.
Oh yeah,
it's a wonderful image.
What's amazing about it's always amazing to me how you can see the star color. It really emphasizes that stars have different colors, and that's primarily due to their surface temperature. So that for some reason, star trails really, really bring that out a lot more than just sort of looking at them normally.
Absolutely. And some of these images as well just have, in fact, made it into the observatory calendar for 2023. So it was a greatly successful project. And in addition to, wonderful targets to point at, would you say that there's anything really surprising that you learned while doing your event up there, or your tenure, I should say?
Well, one of the things I wanted to do was learn the LX600 system, because that was relatively new to me. So that was sort of good to develop some comfort or a little bit of mastery with that. So that was new. That was sort of uncharted territory for me. But I've used lots of different telescope systems, large and small. So it was just another notch in the bedpost there, another telescope system to learn. One of the really surprising things, this I have mixed feelings about, it's good and bad, but one evening it was very clear and we were just chatting. It was the end of a program. I was chatting with some of the park staff, and I was facing south. The two park staff were looking towards me. They were looking to the north. And one of them said, "What's that?" And we turned around. We all looked at this weird streak in the sky that was moving. And it was quite long. And right away, my thought or experience was, I've never seen this before. And it's the kind of thing where you go, is it a UFO? So I asked the park staff if I could borrow their binoculars, and I looked at it later. But while I was looking at it, they immediately put their binoculars on it, and I said, what are you seeing? And they said, we're seeing a line of lights. And I said, oh, it's separate lights, a bunch of little individual points of light. And they said, yes. So I knew right away what it was. It was a recent launch of the Starlink satellites by SpaceX, and I had been monitoring the launches, and the launch had just gone off that afternoon or the early evening or something like that. So when the Starlink satellites are deployed from the rocket after it's launched, they're obviously all really close together, and they're let go in the same path and same trajectory, and they're maybe just meters apart physically, but over time they'll spread out. That's the plan, is that they get widely dispersed around the Earth to be part of the mesh network for the whole Starlink system. But when it's first deployed, they're like right behind each other. It's like cars on a highway or the lit windows of a train at night. So it was really fascinating to see that. We saw it again like a couple of nights later. There was another launch again. So that was a new experience that I had. I've never seen this kind of thing in the sky before, and I had to sort of quickly figure out and identify what it was.
Yeah, and of course we're now seeing more and more of those. Unfortunately, they are, well, for better or worse, they're becoming quite common. The Starlink launches, and it's a lot of that. Is, as you say, a very two-edged sword, because the Killarney Provincial Park does, I believe, have Starlink internet now, which helps with connections, but it's also a bit of a nuisance when it comes to actual observing. So, yeah, that is really interesting. Now, I want to make sure that we have at least a little bit of time to talk quickly about your RASC observing programs as well, because you work with the RASC on observing programs with certificates, and that was a really cool thing that we could actually make sure to offer people up at the parks. Were you able to do any work with that while you were up?
We talked about it, that the Royal Astronomical Society of Canada has a number of observing programs, and there's a really great one, kind of an entry-level beginner program that doesn't require any equipment. You can do a lot of the objects with your eyes. If you want a better view of some of the objects, you can use binoculars. But the Explore the Universe program is a really great one that anybody can do. Also, what's good about the program is people don't have to be a member of the society. It's open to the public. So there's a number of objects on the program, a number of targets. It totals around 100 objects, but to be certified, you only have to do half of them. So 55, I think, is the minimum requirement. So again, it's easy to do. It's an entry-level program. It's a good cornucopia of objects too. You're looking at the moon, some planets, learning some stars and constellations, and being in a park, particularly a dark park, is a great way to do that and get started. So we didn't do a lot with it this year, but I'd really like to encourage that. I was thinking sort of doing kind of coaching in the daytime, helping people with the program, explaining how it works, and then having an evening session where we could work together and find some of the objects and start to tick those boxes to help people begin to work through the program and begin their journey to get certified as an Explore the Universe observer.
Absolutely. And of course, if anybody listening sounds really interesting to you, the Explore the Universe is on the rasc.ca site under certificates programs. So rasc.ca/certificate programs, nice and easy to find. And it is something that you can work on even when there's not an astronomer in residence. So the astronomer residence program for 2022 has stopped, but it will start up again in May of 2023. If you don't want to wait for us, please do feel free to wander over to RASC and check out their, especially the Explore the Universe certificate. It's very, very cool stuff. All right, well, that is almost all we have time to fit to print. So, Blake, do you have any any sort of last thoughts on your program or favorite memories you'd want to share about the Astronomer in Residence, or recommendations?
I just want to thank you for nudging me or reminding me that I could apply for it. So it was a real treat. I love camping. I love astronomy. So whenever I can do those things together, that's always a real blast. I really enjoyed being there. I've been to Killarney before, but it was really a lot of fun being at the observatories and having access to that equipment. I'm also a gearhead, a techno geek, so I loved playing with all of the equipment and learning that and making it work properly and then helping others. It was also a real pleasure building those documents and helping the other people get up to speed, and all the guests of the park and also the park staff that I was able to help out. That I really enjoy that. I just love sharing my interest and my passion in astronomy and being able to help Catherine and Kate and all the other park staff there. That was really good. But I have to thank you and Bruce for all of your support too. Couldn't have done it without you.
Well, we're lucky to have you, and of course, as a reminder, we will be trying this again next year. But you don't have to wait for us. There's all kinds of stuff to see tonight and for the whole rest of the winter. Just make sure to bring your warm coat if you go out tonight, because it is. I was out earlier and it is properly cold out there. So we'll go ahead and I think we'll quickly mention just at the end of this segment. We've only got 2 or 3 minutes, but I did want to tell everyone about a really interesting article. We have, per usual, we've done the news article all the way at the end, but in Universe today, there is a lot of chat about life on Mars again. And of course, with the upcoming NASA Artemis launch happening maybe on Wednesday again, we have this whole back to the moon Artemis plan. Of course, going back to the moon, putting humans on the moon, having the lunar gateway up there, having a human landing system, a base camp on the moon, and then perhaps back to Mars. Well, there was an article earlier this year, so about a month ago in October, about how life might have gotten sort of wiped off of the surface of Mars. There have been a lot of theories on this over the years, and of course, we're sure that ancient Mars did have water on its surface, and this was it's actually called early life on Mars might have wiped out life on Mars. And the idea is, of course, that the microbes that came into the Martian atmosphere would have been something like methanogens, and they would have initiated a global climate cooling by changing the atmosphere's chemical makeup. So it's really interesting times in astronomy, and especially in the area of talking about, life on Mars. If these microbes did cause Mars to cool, well, would they have moved underground to find an alternate source of energy? And if those microbes did move underground and evolve, by changing the what does that mean chemical makeup? Potential human really, settlement, or of course, interesting times possible in human interference and life that might already be there. The area of talking about really fun topic. Unfortunately, I think we're not going to be able to debate it too much. Mars to cool. Because we do need to wrap up tonight's show to find an alternate source of energy. But and if those I think I'll just take our last couple seconds here and say thanks again to Blake Nunro for joining us tonight. Of course, possible human interference. Blake, any last thoughts from you? Either the area.
Thanks for having me.
About really fun life on Mars. I think we're not going to be able
fun
to debate it too much.
I had a great time.
Well, absolutely, you're welcome back anytime. We'll talk more about Mars later, I'm sure. And I'll go ahead and say thank you to everyone who has been listening. Blake Nunro, University of Tonight's program presented by student faculty and friends. You can always catch us on Twitter. Really fun. Facebook or Instagram. Check our website to post and update at www.ca. Thanks for tuning in. Clear skies and
Radio at astronomy.fm. Thanks so much for being part of the Voices